Hi.
Well, you got to do something to attract an audience. You know, my contributions to Rosetta Code are not limited to Ford. My most recent contribution, however, is in C. Let's take a look at it. Yeah, it's nice and short. But this version is derived from Ford? That's not even the same language family. For Pete's sake, how do you get from this to this? Frankly, it's an interesting story. As you might know, I wrote a basic interpreter in 40H, and it's got its own page on Rosetta Code, with close to 200 tasks fulfilled. To get to that number, you have to write a program in it from time to time. And the cantor set task seemed like a nice one to get done. But there was one problem. All the examples required over 400 elements. And the array that comes with uBasic Ford, that's how it's called, has only 256 elements. Of course, I could have packed multiple values in a single element. I've done that before. Even making a bitmap out of the whole shebang is no rocket science. But I thought, let's see what more is there. And yes, I found something suitable. A Ford version, requiring only 81 elements. Well, that's reasonable, I thought. But how do you get from a stack-based language like Ford to a variable-based one like uBasic Ford? That was much easier than you thought, because I have a secret weapon. A Ford to uBasic Transpiler. The only thing I had to do was to port the program to this dialect. It doesn't have its own variables, it simply uses the uBasic Ford variables as values. Yes, the Ford-like values, the ones that work with 2. First I had to port it from Ford to 40H. That was pretty painless. I just had to hide 2 words. Because you just can't redefine words in 40H without hiding them first. Once I had that running, I could port it from 40H to uBasic Ford. And so variable length became value L, string $, became value S, and finally constant/width became value W. Yeah, the support for types in uBasic Ford is rather limited. The next step, of course, was to adapt this program to the string handling routines of uBasic Ford. And after that, all I needed was to define a blank-like word in uBasic Ford, which had just become easier because of the poke command I'd recently added. See the previous episode. And then it ran. Job done, you'd say. Because what the Transpiler outputs is pure uBasic Ford code. It may appear peculiar, but it is what it is. The subroutines at the end are the operations where the order of the operands is important, or, if you prefer, the non-commutative operations. But of course, you can take it a step or two further. Like, let's move go up, at a proper end at the main routine, and let's remove the if 0 then and if pairs that isolate the subroutines from the main program flow. Clean the indentation up and we have a source that already looks much better. Now let's see if we can unfortify expressions, e.g. push s, print show pop, print simply equals print show s. I mean, s goes on the stack, is pop by print, semicolon prevents a new line, next print adds 1. It boils down to this. By the way, show shows the string a string pointer points to. Try saying that 3 times fast. Same thing with push L, push 3, proc div, L is pop. L is pushed, 3 is pushed, div lends a quotient on the stack, which is assigned to L. So L is L divided by 3. Push L, push pop plus pop becomes push pop plus L. And this is a tricky one. Push L, push 1, proc greater, push pop equals 0. The first part collapses to L greater than 1. The second part equates that expression to 0. So push L greater than 1 equals 0. Similar, push toss, push W, proc less, push pop equals 0. First, tos less than w, then push tos less than w equals 0. And yeah, tos means what you think it means, it is equivalent to rfetch. Now let's integrate a few of these smaller subroutines into the program. Print, it's gone. Say goodbye, bye bye. Let's take a look at skip. After whole renders true, it is called 3 times. When false, it is called 2 times. Or is it? Note that wipe also calls it, at the very end. So if we remove it there, we can be assured that the 2 times skip is called can be moved outside of the conditional, because the sequence is identical in both branches. And since skip is equivalent to push pop plus L, this renders to push pop plus L plus L. And let's simplify it the untils. Done was called right before until pop. Done equal to L greater than 1 equals 0. So the actual expression was until L greater than 1 equals 0, which is equivalent to while L greater than 1. Same with lowercase done in split. That one equals to tos less than w equals 0, which become until tos less than w equals 0, which can be simplified to while tos less than w. Now let's take the stack out of the equation. It is much more shallow than you think. You see that push 0 there? Let's assign it to a variable, to n. Now the entire thing collapses. While tos less than w becomes while n less than w. The whole subroutine now become if peak sn doesn't equal ort space, then proc blank. And for that we can now take the last skip remains out of the conditional. And now we have a nice ogle-like split. Reintegrate step and blank into split. It's easy, you can and we're done. There's absolutely nothing left that reminds us of the original Ford program. Well, except for all those superfluous subroutines. Just get rid of them. And while you're at it, take care of that transpile message, will you? And then I thought, let's make this joke complete. Let's make it into a C program and post it. And there you are, a C program derived from a Ford program. I guess there are people looking at the C program, then the Ford program, thinking, what? And ending with those blank expressions on these astounded faces. I'm Hans Beesmer, and this was Back and Forth.
Marmalade, get in here. We got our first subscriber.